this protein, which is stuck to the receptor. This is the glucagon receptor protein. So this protein, this G secretory protein, is composed of 3 subunits, alpha, beta, and gamma. So when it recognizes that glucagon has docked to the receptor part of that protein, GTP gets reset to GDP. And then it gets converted back to ATP because you've broken off this one part, and then like GTP goes to GDP means that there's a phosphate loose and you got to put it somewhere, so it goes from ADP to ATP. When that happens, the alpha subunit separates. The alpha subunit travels from the receptor protein to adenylate cyclase, which is also embedded in the plasma membrane. When that alpha subunit docks onto the adenylate cyclase, which is embedded in the plasma membrane, what happens is there's an ATP associated with this protein. It gets converted to cyclic AMP. So right now, everything's happening to the cell surface. The only part of the cell that is aware that glucagon has shown up is this little part right here, where it is docked to the surface. Once cyclic AMP is activated, that cyclic AMP is liberated and it can travel to a different part of the cell. That's what makes it a second messenger, because it's taking the cell message that has happened at the surface, and the cyclic AMP can travel to wherever protein kinase A is. And again, we're talking about probabilistically. Protein kinase A is floating around, the cyclic AMP is now floating around, and they're going to run into each other. You have more than one glucagon receptor in your cell, so this is happening multiple times. So that's step 4, that cyclic AMP can leave the cell's membrane surface and then bind to the regulatory subunits of inactive protein kinase A, which activates it. Okay, and that's shorthanded in my number 5, activates protein kinase A. Question?
So CMP would be kind of like the middleman relaying
Exactly.
message from when the moment that the glucagon enters, as you said, which causes the reaction, to the point in which CMP delivers the message to where it needs to be.
Right. So the second messenger is the one that delivers the message. In this case, it's cyclic AMP. We're about to look at another one which has a different set of second messengers, which does 2 different things. But